Example 9. So what we're going to do another one of those notice type of things. So I want to point out that 7 to the x to the 2 is the same thing as 7 to the 2x. So 7 to the 2x is the same thing as 7x all squared. Okay. Well, let's really do example number 9 now. So we're going to have 2 to the 2x minus 10 times 2 to the x plus 16 equals 0. This question's a lot of fun. It's going to incorporate a lot of things that we've done before. So first things first, we're going to use this trick over here. So 7 to the 2x is 7 to the x squared. So 2 to the 2x is the same thing as 2 to the x squared minus 10 times 2 to the x. I move the bracket, doesn't really matter. Plus 16 equals 0. But now I'm going to do something special. I'm going to do something pretty special here, actually. What I'm going to do is I'm going to do a substitution. I'm going to say, I'm going to let a, some random letter, I'm going to let a be equal to 2 to the x. So what happens now is 2 to the x just becomes a. So we end up with a squared minus 10 times 2 to the x, which I'm going to say is a plus 16 equals 0. Now we're going to have to come back to that, so we definitely need to remember this. So we said that a was equal to 2 to the x, and we are going to come back to that. So now what does our equation look like? What we have is our equation has now become a squared minus 10a plus 16 equals 0. And this is a quadratic, and we're going to solve it by factoring. And this factors into our quadratic formula if you felt like it. We were unable to factor. So a minus 2 times a minus 8 equals 0, which means that a minus 2 equals 0, or a minus 8 equals 0, which means that a equals 2 or a equals 8. And those are the solutions for a. But a was equal to 2 to the x. So a was equal to 2 to the x. What that means, though, then, is that 2 to the x equals 2, or 2 to the x equals 8. We could solve both of those equations. So how would we solve it? Now we're back to the usual stuff. So this is going to be the same basis. This is a little bit weird if we look. So that's a 2, and that's a 2. The exponent there is x. The exponent there is missing, which means there's an invisible 1 over there. So x equals 1 is one of the solutions. This one over here, we're going to have 2 to the something, and 8 is the same thing as 2 to the 3. So 2 to the x, 2 to the 3, the bases are the same, so the exponents are the same. X equals 3. And therefore, those are the solutions. The solutions are x equals 1 or x equals 3. So the solution to these equations are x equals 1 or x equals 3. Let's quickly check if one of them works. So let's say we have 2 to the 2x minus 10 times 2 to the x plus 16 equals 0. We think that 3 is a potential solution. So that's going to become 2 times 3 is 6, minus 10 times 2 to the 3, plus 16 equals 0. 2 to the 6 is 64. Minus 10 times 2 to the 3 is 8. This is looking good. 64 minus 80 plus 16 equals 0. And 64 plus 16 is 80. 80 minus 80 is 0. 0 equals 0. So x equals 3 is in fact a solution to this equation.